All right, buckle up, everybody, because today we are diving deep into a physics paper that's causing quite a stir.
It really is. It's called the time force hypothesis, a unified framework for energy, time, and matter. And, well, it claims it might just have cracked the code of the universe.
No kidding. And get this, it was co-authored by, wait for it, an AI research assistant called Professor Ripple.
That's right. Talk about next-level science.
We are. But before we get lost in the crazy details, let's set the scene.
Good idea. Now, I think most of our listeners know this already, but
Probably, yeah.
modern physics has a bit of, well, an identity crisis, let's call it.
Yeah. Like trying to jam puzzle pieces from totally different puzzles together. Yeah.
Exactly. Over here, we've got Einstein's theory of relativity, explaining gravity like a champ. Then over there, there's quantum mechanics, nailing the weird world of subatomic particles.
But they just don't play nice, do they?
Not really. And then you throw in the standard model of particle physics, which does a great job explaining the fundamental forces in particles we know and love.
But it still leaves us with some big, fat question marks, right?
It does. Like, where does gravity actually fit in? What's the deal with all this dark matter and dark energy? And the biggest head-scratcher of all, what even is time?
Ugh. Don't get me started on time. Is it a dimension? Is it an illusion? It's enough to make your head spin.
Well, the time force hypothesis, we'll call it TFH, steps in with, well, some pretty bold claims saying it has answers to all those questions.
All of them. All right, you've got my attention. Lay it on me.
Okay, so it all comes down to this one big idea. They call it the equilibrium principle.
The equilibrium principle. Sounds important.
It is, and it's actually pretty simple. The basic idea is that all the energy in the universe, it's always trying to balance itself out.
Like find some kind of Zen state.
Sort of. Picture a super crowded room. Everyone wants a little space, right? Well, energy, it wants to spread out, move from where there's a lot of it to where there's less of it.
Like heat spreading out or water flowing downhill. Always searching for that balance.
Exactly. Now, here's where things get really wild. TFH says this simple principle, energy looking for equilibrium, it's the engine behind everything, literally everything in the universe. Galaxies forming, tiny particles doing their thing, even space-time itself, it's all driven by this.
Oh, well, hold on a second. So space and time, they're part of this energy balancing act, too.
That's the mind-blowing part. TFH introduces this thing called the 4D scalar field. Think of it like this invisible energy field that's everywhere, connecting the whole universe.
Like a giant energy web linking stars, planets, even those tiny particles you were talking about.
Exactly. It's like a cosmic ocean of energy. Now, here's the kicker. Space and time, they're not the fundamental building blocks we thought they were.
They're not. What are they then?
They emerge, get this, they emerge from how this energy field, this scalar field, behaves.
So they're like, what, ripples on the surface of this energy ocean?
Yeah, that's a great way to think about it. Mind-blowing,
Sure,
right?
totally. And that would have some pretty crazy consequences, wouldn't it?
Oh, yeah. For example, if time is just how we perceive energy shifting around in this field, that means time can actually speed up or slow down depending on how much energy is packed into a certain area.
Like how time slows down near supermassive objects like black holes. That's because of different energy levels in the scalar field.
Bingo! And remember how physics has a really hard time explaining why time seems to only move forward? The arrow of time, they call it?
Yeah, it's always a one-way street to the future.
Well, TFH has an explanation for that, too. Remember how we said energy always flows from high potential to low, always trying to find that equilibrium? Well, TFH says that flow, that direction of energy, that's what defines the direction of time.
Okay, I think my brain just did a backflip. So if space and time are just side effects of this energy field, does that mean we have to rethink gravity, too? Because, Einstein's theory, it says gravity is a warp in space-time, right?
Right. But TFH takes a completely different approach. It says, forget that warping business. Gravity is actually a side effect of how the energy is spread out in the scalar field. They call them energy gradients.
Energy gradients. Like, are we talking hills and valleys in this energy ocean now?
Perfect analogy. Imagine those hills and valleys represent areas where the energy density is different. And just like, a ball rolls downhill, stuff in the universe, it's always moving towards areas in the scalar field where the energy level is lower.
So the Earth isn't pulling us down with its gravity. It's more like we're sliding down an energy slope created by the Earth in the scalar field.
You got it. And remember, dark matter, that mysterious stuff physicists say makes up a bunch of the universe, but we can't see.
Yeah, it's supposed to have all this extra gravity.
Right. Well, TFH says, hold on, we don't need to invent some new kind of particle to explain that. Those weird gravitational effects we blame on dark matter, they might just be because of how the energy is spread out in the scalar field, those energy gradients we talked about. It all comes back to energy wanting to be in balance.
Wow. This time force hypothesis is really turning things upside down, taking all these big mysteries in physics and boiling them down to this one elegant idea. But what about particles themselves, like electrons and quarks? What are they made of in this energy-driven universe?
Get ready for this because it's another wild one. TFH says those particles, they're not actually tiny little solid things. They're more like tiny little, well, whirlpools of energy in the scalar field.
Miniature energy tornadoes spinning around in this cosmic ocean. Seriously.
Seriously. But how do they get properties like mass and charge then, right?
Really good question.
Okay, so according to TFH, mass and charge, they're not built-in features of particles. They emerge from how these energy vortices behave, how they spin and interact.
So the way those energy whirlpools spin and bump into each other, that's what gives them mass and charge.
Precisely. And here's another twist. TFH says we don't even need the Higgs field, you know, the one that supposedly gives particles their mass.
Yeah, I've heard of that.
In TFH, mass just pops out naturally from how these energy vortices do their thing. It's a built-in feature, not something added on.
So it's not just giving us new explanations, it's actually simplifying things too, like decluttering our understanding of the universe.
That's a great way to put it. And the best part, unlike a lot of fancy physics theories out there, TFH can actually be tested. It makes very specific predictions that scientists can go out and try to measure.
Oh, so how do we do that? Are we building giant energy vortex detectors or something?
Maybe not giant vortex detectors, but there are a few key experiments that could really make or break this theory, and that's what we're going to dive into next.
All right, I'm ready to get experimental. We'll be right back in the next part to see how scientists are putting this time force hypothesis to the test. Don't go anywhere.
All right, welcome back, everyone. Last time we left off with the time force hypothesis, and let me tell you, it's full of some pretty wild ideas about energy and gravity, even what particles are made of.
Definitely a lot to digest. It really is. But what I find so cool is that this theory is not just equations on a chalkboard. It could actually change how we understand, well, reality itself.
It really could change our whole worldview, yeah.
I mean, just imagine, if this is right,
Yeah.
and space and time are just like ripples on this giant cosmic energy ocean, it makes you question everything.
Yeah. It makes you realize just how interconnected everything really is. That's one of the most profound things about TFH. Forget isolated objects and forces. It's all about this constant web of energy relationships where everything's affecting everything else.
Like we're all connected through this invisible energy web.
Yeah, like that.
Reminds me of the Force in Star Wars, how it binds everything in the galaxy together.
That's a good analogy. And if everything really is connected like that, it makes you wonder about, well, cause and effect, even free will.
Right. If our actions are making ripples in this energy field, could we be affecting things in ways we can't even imagine? Could things happening far, far away be influencing us right now?
It's definitely a possibility. TFH paints a picture of a universe that's way more dynamic, way more interconnected than we ever thought.
Okay, I'm officially having an existential crisis over here. But before I go too far down that rabbit hole, let's get back to, well, some of the more practical stuff. You mentioned that one of the things that sets this theory apart is that it's, well, testable, right?
Exactly. It's not just some abstract philosophy. It gives us concrete predictions that scientists can actually try to verify.
So how do we do that? What kind of experiments are we talking about here? How do we measure these tiny energy fluctuations?
Well, one big one is trying to measure if the gravitational constant, G, actually changes in extreme environments. Remember, Einstein's theory says G is constant, but TFH says, nope, it could actually fluctuate depending on how dense the energy is in a specific spot.
So like if we put an atomic clock somewhere with super strong gravity, like near a black hole, and it ticks at a different rate than we expect,
that's the idea. Those variations in timekeeping, they could be explained by the energy gradients TFH predicts. And remember, according to TFH, G isn't just some random number. It comes directly from how the scalar field behaves.
You also mentioned looking for energy diffusion effects in gravitational waves. How does that work again?
So gravitational waves, they're like ripples in space-time, right? Traveling at the speed of light. Well, TFH predicts that as these waves travel through the scalar field, they should lose a tiny bit of energy because of diffusion.
Like the waves are getting a little weaker as they pass through the energy field.
Yeah, exactly. It would be a tiny effect, but the next generation of gravitational wave detectors, they might be sensitive enough to pick it up.
So if we detect a gravitational wave from, say, two galaxies colliding far, far away, and it's a bit weaker than Einstein's theory predicts, that would be a point for TFH.
Exactly. And there's another really cool possibility, trying to see if the mass of particles changes under certain energy conditions. Remember how we said particles are like tiny energy vortices in the scalar field?
Yeah, those little energy tornadoes.
Right. Well, if we can manipulate those vortices, maybe by zapping them with a super powerful laser or something, TFH predicts we should see a tiny change in the particle's mass.
So we could actually change the properties of matter by messing with those energy vortices. That sounds insane.
It does, doesn't it? And if we could do it, it would be pretty strong evidence that mass is an emergent property, just like TFH says.
All right, so we've got experiments looking for changes in gravity, energy loss in gravitational waves, and mass fluctuations in particles. Sounds like scientists are really putting this time force hypothesis to the test. But let's zoom out for a second. What are the big philosophical implications of all this? What does it mean for how we see the universe, our place in it?
Now, things get really interesting. One of the most profound things about TFH is, like we touched on earlier, that everything in the universe is fundamentally connected. We're not just isolated beings in a vast, empty cosmos. We're all part of this incredible web of energy.
Yeah, we're all connected through this cosmic energy field. But what does that actually mean for us?
Well, it means that everything we do, every thought we have, even our feelings, could be creating ripples in this energy field, ripples that could affect things far beyond what we can see.
Like a cosmic butterfly effect,
Yeah.
where even tiny actions could have huge consequences down the line.
Exactly. Every choice we make, every action, it sends ripples through this web of energy. It's a pretty humbling thought.
It is, but it's also kind of empowering, isn't it? It means we're not just passive observers, we're actively shaping reality.
Exactly. And that brings up another mind-blowing question. If everything's interconnected through this energy field, what about consciousness? Is that part of it too?
Whoa, yeah. Could consciousness itself be some kind of manifestation of this energy field? Like a complex pattern within the scalar field?
Now, that is a fascinating idea. If TFH is right, it suggests consciousness might not be limited to our brains. It might be woven into the very fabric of reality itself.
Okay, my mind is officially blown. This time force hypothesis, it's not just changing how we understand physics, it's making us rethink what it means to be human, to be conscious, to even exist.
That's the beauty of it. It pushes the boundaries of science and opens up whole new areas to explore.
It's like TFH is giving us a brand new way to look at the universe, one that highlights how interconnected everything is, how energy plays the key role, how everything's in this constant dance of forces. And if it turns out to be true, it could change not just science, but philosophy, spirituality, our entire worldview.
It really could. And who knows what other amazing discoveries are waiting for us as we explore this new frontier.
I'm definitely excited to find out. Join us in the final part, where we'll wrap up our exploration of the time force hypothesis and delve into some of the, well, most mind-bending possibilities it suggests. You won't want to miss it. Welcome back to the final part of our deep dive into the time force hypothesis. It's been quite a journey, wouldn't you say?
It really has.
Yeah.
From space and time being emergent properties of a cosmic energy field to particles actually being tiny little whirlpools of energy.
And that mind-blowing idea that everything in the universe could be connected through this energy field.
It really does make you question everything we thought we knew.
It really does. But we've covered the main ideas, looked at the experiments that could prove or disprove it. So now I think it's time for the big question.
The big one, yeah.
What does this all mean? I mean, for us, for how we understand the universe, the whole shebang.
The ultimate implications, right. If TFH is right, it's not just a scientific revolution, it's a philosophical one, even a spiritual one, I'd say.
Absolutely. Let's start with the science side of things. Physicists have been searching for this theory of everything, for ages.
Yeah, a single framework to explain all the forces and particles in the universe.
The holy grail of physics. A theory that could finally bring Einstein's relativity and quantum mechanics together.
Exactly. There have been lots of attempts, but none have really nailed it yet. But TFH, well, it offers a real possibility. It suggests a way to reconcile those two seemingly incompatible theories.
So TFH could be the missing piece of the puzzle.
It could be. And if we can achieve that unification, who knows what we could understand? The Big Bang, the tiniest particles, everything in between.
But this goes way beyond just physics, doesn't it? If everything's interconnected through this energy field, that changes how we see the world, how we see ourselves.
It changes everything. Think about it. Every choice we make, every thought we have, every emotion, it could be creating ripples in this field, ripples that go way beyond what we can perceive.
A cosmic butterfly effect, right?
Exactly. Even the smallest actions could have huge consequences in the grand scheme of things.
That's both a humbling and kind of terrifying thought, isn't it?
It is. It means we have a responsibility to be aware of what we're putting out there, because it could be affecting the world in ways we can't even imagine.
We're all part of this cosmic dance, and every move we make changes the whole choreography.
Beautifully put. It really makes you appreciate the interconnectedness of it all.
But it also raises the question of free will, doesn't it? If we're all connected through this energy field, are our choices really our own?
That's a question philosophers have been wrestling with forever, and TFH doesn't give us a clear-cut answer, but it does give us a new way to think about it.
I guess it comes down to how much influence this energy field has on our decisions. Is it a guiding hand or just a subtle background noise?
That's the mystery, isn't it? It's a testament to how TFH challenges our assumptions, makes us question what we thought we knew.
So big implications for science, philosophy, our sense of self. But what about technology? Could this lead to, I don't know, new gadgets, new ways of doing things?
Oh, absolutely. If we can learn to manipulate the scalar field like TFH suggests might be possible, the possibilities are, well, almost limitless.
We're talking artificial gravity, unlimited energy, maybe even, I don't know, time travel.
It might sound like science fiction, but that's often where the biggest breakthroughs come from, right? Someone imagines the impossible and then figures out how to make it happen.
That's the spirit. In TFH, it's a perfect example of how theoretical physics can inspire us to dream big.
To push the boundaries of what we think is possible.
But even if those futuristic technologies are still a long way off, TFH has already given us something incredibly valuable, a new way to see the universe and our place in it.
A new perspective.
It's a perspective that emphasizes, well, connection, the importance of energy, how everything is constantly interacting and influencing everything else.
It's a more holistic view.
Exactly. And that shift in thinking could change how we approach, well, everything. Science, the environment, even how we treat each other.
It reminds us that we're not just individuals, we're all interconnected, part of something much bigger.
Threads in the cosmic tapestry, you could say.
I like that.
And that's a powerful message, a hopeful one, I think.
It is. It encourages us to live with more meaning, more compassion, to take care of our planet.
And who knows, maybe even unlock those amazing technologies someday. The time-force hypothesis, it reminds us that the universe is full of mysteries, and that's a good thing.
It is. It keeps us curious, keeps us exploring.
So keep those minds open, keep asking those big questions, because who knows what incredible discoveries are waiting for us out there.
Thanks for joining us on this deep dive into the time-force hypothesis. It's been a pleasure exploring this fascinating topic with you.
And remember, the universe is vast and full of wonders, so keep exploring, keep learning, and most importantly, keep wondering.